Hey everybody, my name is Erika Sanborne, and in this video I'm going to talk through the basic logic of null hypothesis significance testing and also interpreting that p-value that you get from your software output, SPSS or STATA or whatever. My background is that I have taught statistics for many years at the University of Massachusetts in Lowell and elsewhere, and I really like making things accessible. In fact, I taught mostly statistics for psychology majors, and people majored in psychology specifically because they're afraid of math. And so it was truly joy to be able to put this in reach and help them to get it, which I find works well when one understands the basic logic of what we're doing. So that's all I'm going to talk through, the logic of null hypothesis significance testing and interpreting p-values. So much more I want to say, but I'm going to cut it to that. By the way, my laptop is wrecked in the shop, so talking on my cell phone in my dining room. I wish I could create a bunch of animations to point at, but I don't have my computer, so you're just getting me talking. Hope this is helpful. All right, so null hypothesis significance testing. You start with, you're a researcher and you have a question. Your research question, something like, does drinking water reduce migraine frequency? That's the basis of your research hypothesis, which would be, in this case, drinking water decreases migraines. Null hypothesis is not that. So our null hypothesis in this case would be drinking water does not reduce migraines, right? So you use some method, get some data. There's a lot of test options that I'm not talking through in this video. And then you put all your data into SPSS or STATA and you get some output that gives you a p-value. All right. We had our people, drink water and then we tracked their migraine frequency, and our sample had fewer than average migraines. That's cool, but I mean, is it significant? We need to look at that more closely. So all right, we get a p-value. Let's say we get a p-value of p equals 0.20. What does that mean? Can we say anything about the research question? No. Leave it. In fact, take the research question, research hypothesis, or alternative hypothesis and set that aside, because you're not even testing that. You're testing your sample statistic against a comparison distribution based on the null hypothesis. That's why it's called null hypothesis significance testing. Our null hypothesis was that the water didn't do shit, right? Like, null hypothesis was drinking water does not reduce migraine frequency. We got our sample. Our sample on average had, a better than average month. It had fewer migraines than average, but it's normal distribution. Literally half the population has better than average. So that doesn't tell us anything. P-value 0.20. What does that mean? P stands for probability or percent. Usually means probability, but it's also equivalent to a percentage. P of 0.20, that tells us our sample is likely to occur, that sample, or something even better, 20% of the time, or 0.20 probability for getting a sample that extreme if the null hypothesis is true and the water doesn't do anything. Well, that's a fairly common result then, to be, so they're in like the best 20% of migraine sufferers, our sample. Okay, that's not impressive enough for us to reject the null hypothesis, because people have all different frequency. There's all different explanations for variation, and that our sample's in the best 20%, it's not impressive enough that we can say that our variation from the mean is, in part due to our independent variable. It's just not an impressive enough sample. So we do not reject the null hypothesis, which again said that drinking water does not reduce migraine frequency. We cannot reject that and give the sample size in reporting that result so people know what you did. Let's say you get a p-value of a small number, like p equals 0.002. All right, what's that mean? That's a tiny p-value, so people think of that as good. Make sure you don't think of it as very significant. That's not a thing. It's probability. It's just very unlikely to get that sample by chance if the null hypothesis were true. It's possible 1 out of every 500 samples would get that score or better, but that's impressive enough that we reject the null hypothesis that says water doesn't do anything for us, and say that our alternative hypothesis is kind of supported by this study. We're still not decisively answering the research question and saying, yes, drinking water reduces migraine frequency. That's way more bold than what we have a right to claim with null hypothesis significance testing. We reject the null hypothesis that says there's nothing going on. We say the hypothesis that there's the water reduces migraine frequency is supported by this data. That's as strong a conclusion as you can really make, because the same variation that exists in the population that accounts for, just variability in migraine frequency in general, that is also present in our sample and could very well have explained why we got this 0.002 p-value. It's in the rejection region if we test at the 5% level of significance, which is saying we need our sample to be in the most extreme 5% of this distribution for us to reject the hypothesis that says there's nothing going on and say, no, alternative hypothesis supported. So 0.002, that's way better than most extreme 5%. So we have a significant test. Don't speak to effect size with that. This has nothing to do with, well, how much credit can we give to the independent variable? Like, how much of an effect did the water have on the migraine frequency? We're literally not even talking about that right now, okay? So something can't be very significant and you didn't get a big effect. Don't use those words. All you have is a statistically significant test at a p-value of 0.002 that lets you reject the null hypothesis and give some credit to the independent variable in this instance. So much more I'd love to say, but I'm trying to keep this brief, so I hope this was helpful, and good luck.